Welcome back to Big Data Analytics and Cloud Learning from RGS. Today I want to introduce the numbers or related to the data sets that you deal in your big data project. Is it really worth knowing? Let's see how useful it is. So I'm just going to give you an introduction to big numbers worth knowing for big data. Let us understand. So in our data size list 1, the lowest size is 1 bit, right? The 1 bit can only store one binary number, which could be either 0 or 1. So in digital world, if the bit is, represented as on off, 0 means off, 1 is on. So we will not go in depth about how this bit is stored in the actual, circuits. Like if you could recollect your studies from engineering p-n junction diode and then forming a transistor NPN and PNP and then like a flip-flop to store the bit like RS and JK and so on. So we will not go in that much detail. So what we are going to see really is that when we represent our data size with a specific identification, what is the maximum, what is the number we are talking about? So that is what we are going to see. Okay, with that, let's go to the next one. The data size 2 is 1 byte. 1 byte is nothing but an aggregation of 8 individual bits. Remember, one bit can store either 1 or 0. So when somebody says 1 byte, you're storing 8 values, which could be a combination of on and off, which means like ones and zeros. And that much is required to store one character. Okay. So the next one is data size 3, 1 kilobyte. 1 kilobyte is 1000 bytes. So we just saw that in 1 byte you can just store one character. So this is equivalent to you typing a short email or writing a couple of statements in a text file and storing that. And then when you go back to the file and right click and see the properties, you could see the file size in kilobytes, right? So what happens if the file size content exceeds from few lines to few pages? So that's where we are talking about megabyte. 1 megabyte is 1000 kilobytes. So you could see the zeros increasing, right? So to give you an idea, when you send an email, let's say, you attach sometimes a file, maybe it's in MB size. For example, when you send your any attachment, email attachment, the file size could be in megabyte, right? So the next one is 1 gigabyte. 1 gigabyte is 1000 megabytes. So in terms of zeros, you could see it is adding another 3 zeros. So how do you equate this with an analogy? Remember those DVDs and CDs where you use them to watch movies or audio or any other content? So that's the size we are referring here. The DVDs are around 4 GB, 4.3 GB, right? That's again a small data for big data technology, because there are a few more to go in this list. Let's go from gigabyte to terabyte. So 1 terabyte is equal to 1000 gigabyte. So how much data you can store? So that's the number given in terms of bytes. For example, in New York Stock Exchange, every day the transaction data worth of 1 terabyte is collected for later analysis or processing. And there could be many more examples. I just want you to have an idea when you hear any of these data size, what would be the approximate size of the data, I mean the size of the data set that you can relate. The next one is a petabyte. The petabyte is 1000 terabyte, and you could see the zeros increasing. So where do you get this much data? To give you a simple example, in Walmart, every hour from 100 million customers, the transaction data is stored, which is around 2.5 petabyte. So that we are talking about just for an hour. So what happens if the store is definitely open for more than 7 hours or 8 hours, and you've got multiple stores and you've got multiple locations? So you still need a bigger number to represent that much data. So let's go to the next one, the 1 exabyte. You could see the zeros in terms of bytes representation. So 1 exabyte is 1000 petabytes. If you still want to represent more data, you go to 1 zettabyte. 3 more zeros added to the exabyte. And 1 yottabyte is equivalent to how many bytes? Let's count the zeros here. It's 1000, 1000, 1000, 1000, 1000, 1000, 1000, 1000 of bytes. Yeah? So in every slide, when I move from data size to the next number, you add 3 more zeros, which is every 1000, right? So the next one is 1 zettabyte, so which is 1000 yottabyte. And the 12th one is Salon-byte, which is 1000 zettabyte. You can see the zeros. It takes a while to count the zeros in terms of bytes representation, but that's the number we are talking about when it comes to big data projects. And the last one in the list is byte. Right? It's a little difficult to pronounce it. My pronunciation is not that great. I apologize for that, guys, but the point is to make you understand. When you deal with big data project with a large sets of data from very large customer like Walmart or any other transactional data that you can think of, which is in thousands of petabyte or even bigger than that, you need to have these terminologies, this representation in your mind to, document it meaningfully for your project or to explain to your customer, because the data size, the data sets will have a large implication on your big data cluster design. If you are doing MapReduce, like your Hadoop MapReduce cluster size will be depending on the data sets that you're going to deal with it. And also the algorithm gets complex because you're dealing with large sets of data. So it has got multiple factors to consider. First of all, like you need to decide how you're going to divide this data, how many cluster nodes you're going to have it, and each of the node will take how much time to run your MapReduce algorithm. So you have to take an optimal decision to balance it out. So we will talk about all those in another, video. And for this video, I just wanted to give you a quick, introduction about the numbers that are worth knowing for big data. Thanks for watching. Please subscribe to my channel if you like my videos. I'm going to come up with more videos on big data and the associated technologies. Thank you. Bye.